for people. Thank you to anyone who's stuck it out all the way to the end of the meeting, particularly those of you for whom we're already deep into the weekend. I'm Martin, and I think you know Zahed, our newish TSV AD. Let's move right along because it is late. You're probably all familiar with the note well by this point. If you weren't at the beginning of the meeting, just be nice and don't spill any APR. Okay, this is the agenda. We're going to go through our usual update on the area, and then we have actually 2 technical items for you today. This is a 2-hour slot. I really hope it won't take 2 hours. One is a dispatch type discussion about draft Z route, which is a document that's currently in the independent stream that has some sort of transport implications, and we'll see if there's interest. And then secondly, COAP has been plugging away in the art area for a while. I think most of you know what COAP is. It has acquired more and more transport characteristics, and Zahed and I thought it would be useful to just sort of brief the area on what's going on and just kind of alert them to the transporty things happening in that space. And then finally, our customary open mic, which doesn't have to take 15 minutes if there aren't that many comments. All right. Does anyone like to bash the agenda? All right. Here's the update on all of our working groups. The most salient issues here are that both Alto and DTN are in the midst of recharting processes. Alto is a little further along than DTN. And also that Vijay Garbani, after 7 or 8 years, is stepping down as one of the working group chairs. They're going to go to 2 chairs for the time being. So thank you, Vijay, for everything you've done for your working group and the area and the IETF, if you're out there, and I don't think you are. Notably, probably a pretty red letter moment is 793 BIS, the venerable spec for TCP, is going through IETF last call right now. So that's a pretty big moment. And thank you to Wes and the other contributors for moving that document through. Right. Anything else that you would like to highlight, Zahed?
That's a very good summary. Yeah, I think the DTN rechartering is having some discussion, and also Alto that people might want to look at, right? Otherwise, I think we're progressing well, and we have something that is in the editor queue and in the last evaluation. So yeah, looks good.
And thank you to our chairs, who I would say by and large did an excellent job of keeping us on time despite some serious time constraints. I thought it was an especially good job to this time around. This is our. Did I skip a page? I think I did. Yes. So some very, very important things made it to RFC in the previous interval. Mainly the whole batch of quick. HTTP3 is delayed for kind of well, it was bureaucratic document reasons, but now maybe there's a little bug they have to fix. Hopefully that won't take too long. And the other one was 9065, which is the transport encrypt draft, which was a long and torturous route. But congrats to the authors there for getting that through. And we only added 2 documents to the queue, although another batch of 5 or 6 will be coming in shortly, I believe. And then this is my every meeting pitch for the TSV review team. I as an AD, I find it extremely helpful when members of the team, conduct early last call reviews of documents to give us another set of eyes from a transport perspective to make sure these documents are okay. And I encourage you to contact Magnus or Wes if you're interested. Magnus, of course, is rejoining the TSV art after being our AD for a number of years. But to contact either him or Wes, or for that matter, the ADs, if you're interested in joining the TSV art, the number in parentheses is how many drafts they had to do in the last cycle. And I think the evidence is strong. This is not an incredibly onerous workload. So if you would like to expose yourself to a little bit more of what the IETF is doing outside the area, I think TSV art is a good way to do that while being very helpful to your friendly area directors. So thank you to our review team. And that's it for the administrivia. So let's jump right into Walkar's talk. Would you like me to drive, or do you want to present the slides?
Yeah, let me try to share my screen and see what it works. Um, no, I'm not sure which of my screens am I presenting. So yes, share my screen. Okay. So let's go up. Good. So thank you very much. This is my 10-minute summary of what this draft or what this technology is about. Root, this ID that is being discussed and is being reviewed. And go to the next slide. So what I would like to do is just like in 5-6 minutes provide you the summary of what is the background of this technology, how does it relate to adaptive streaming technologies, what is real-time object delivery, so the relation of it with IP multicast and other existing technologies like 3GPP and BMS, and how does it relate to ATSC and DVB. Then I'll discuss briefly what is the status of this currently, this ID, and what are the next steps that we would like to do moving forward. So very briefly, the relation of this root protocol is to the adaptive streaming technologies. So here I'm showing the high-level architecture of DASH, which is the Dynamic Adaptive Streaming or HTTP, the MPEG standard, but it is equally applicable to other adaptive streaming technologies like Apple HLS. So this standardization in MPEG was happening in 2010, and the high level, how this technology works is that this is driven via HTTP server. So you segment the content that you want to stream and put it on an HTTP server, the various qualities of the content, and each quality is then segmented into small chunks of data, 1 or 2 seconds each. And then there is a MPD or a manifest file that describes this content that is also put on the HTTP server. So the basic technique is that you switch all the smartness to the client side. So the client accesses this manifest and then selects and adapts the content that it wants to stream so that it can adapt to the network conditions. So all the smartness lies in the client, and this is the common concept with HLS itself. So then, okay, this is HTTP driven technology, and then all of a sudden it was quite a big or important drive to use the same content over IP multicast, and there are then a lot of obvious questions that arise that why Dash is designed for HTTP based mechanism, and the notion of adoption is in any case quite a bit alien to this multicast delivery. So why would anybody want to do this? Obviously, the highest level or the important aspect is to exploit the commonality of ecosystem, which is in easy speak is you want to reuse the content that content providers have. So this is the biggest headache, that you would like to use the same content that you've used for that you've generated for unicast, that you can deliver the same content over multicast, and at the same time you could reuse your players and all the rest of the ecosystem that is common with the unicast for the multicast. So on the left-hand side, you see the typical Dash protocol stack. So you have Dash over HTTP, TCP, or IP unicast. And on the right-hand side, you would like to do the same thing over IP multicast. So obviously, when you want to support the same thing that is working on unicast over IP multicast, you need a different protocol stack. So there are some question marks here. And for the sake of simplicity, let's say in the most common deployment, where you just pick one quality of video and you stream it over IP multicast. So you don't, right now, we don't focus on the adaptation aspect. So one of the earliest use cases of this, or the applications of this, was in 3GPP usage over EMBMS. So in EMBMS, or in that 3GPP environment, Flute was already a known protocol, which is RFC 6726. This was existing at that time, and this protocol is used for IP multicast delivery of files. And now, the most straightforward approach that was adopted was to use Flute to deliver Dash, because Dash, as we described a few slides earlier, is a large ensemble of files. So, well, Flute was used to deliver files, and then you could use Flute over UDP over IP multicast to IP multicast these small chunks of files to the clients. One of the difference that you can note is that Dash is obviously built for HTTP streaming. So this comes with the assumption that the delivery is reliable, but in this case of UDP, it is not. So then you have to use the mechanisms of forward error correction together in Flute or unicast repair to guarantee that the player that is working on the highest level can assume that the content is delivered. So this is how it was used in LTE MBMS. And then, so LTE MBMS, this was 2011, and then towards 2014, ATSC for TV type of broadcast environment investigated further how to optimize this protocol for their uses, and there was a need felt to improve something over Flute. Why? Because Flute traditionally was designed for delivering very large files, typically over their updates and like, and so it's kind of heavy on the amount of metadata that it uses for a given file. And the difference now with Dash is that you have a very large number of small files. So you just consider just one audiovisual representation with 1 second chunks of data, then 3,600 files in 1 hour. So the amount of metadata kind of stacks up, and also the real-time delivery constraints. So you would like to optimize in terms of latency as well. So to minimize the end-to-end delay, so you want to do some optimizations there as well. So this is where Root came along. Some optimizations were implemented in the sense that the metadata was reduced significantly, so that it's much better adapted for these very large number of small files. And some of the mechanisms to do this was to embed the metadata into the packet header itself, and not having this to stream a large amount of metadata together with the files. That is the traditional approach in Flute. So this is the reference to the ATSC specification that was done in 2019. The publication was done in 2019. Here it says 2014, where the whole thing started, and so on. So this was the initial standardization of Root in ATSC. Yeah, here I'm just comparing the protocol stacks. So we said earlier on that the commonality of the formats enable also this notion of hybrid delivery, that since you have the same format, you can deliver it over unicast and multicast at the same time. So you can enable this kind of hybrid delivery where you're combining unicast and multicast to create presentations. Okay, so some further technical details on Root. So here's a function block diagram that is also taken from the internet draft that we have. So the application objects, which are the Dash objects, are taken up by this root sender, and the underlying protocol LCT is used to deliver this over UDP IP. And then there's several type of metadata that is to be delivered to the root receiver on the other end. So the metadata has these 3 categories. There are LCT packet headers and the header extensions. There are file-related metadata. What is its location? What is its size? This can be either embedded into the packet itself, or it can be a separate file as an EFTT. And then there is some service level signaling required to set up the session, what are the IP addresses, the ports, and so on and so forth. So this would be the metadata, and then the main data is sent over this LCT over UDP IP. On the receiver side, you do the source object recovery, and there's optional this FEC or repair object protocol. So you optionally you're sending these repair objects that you receive, and you can use these repair objects to optionally repair your received source data. And then once the repair is done, you put the objects into this application object cache, which is then delivered to the application. So these are some of the further technical details. And okay, so 2014 started this ATSC standardization, and somewhere in late 2017, there was a need in another STO, DVB, and we started to use or add the profile of route delivery into this DVB specification, which is now published, digital video broadcasting. So here's the reference to this HC specification. This was done late 2017 and 19, and during the standardization phase, actually we kind of realized this before, but it was quite strongly felt during the standardization that we were referring to the root protocol in ATSC, but the ATSC annex was probably not the best independent reference source for root. Why? Because how it's specified in ATSC in the annex, it is heavily linked to the ATSC A331 service layer. And, you know, would it be, if you pick up ATSC or DVB or any other standard, it will need its own service layer. So this is why it was very tricky kind of how to refer to this root protocol in itself. And at that time we did it by, you know, we were carefully profiling out and profiling things in the ATSC specification. We were referring to very exact subclauses. We even had to sometime reproduce text of the specification to make it clear. And that was the time, I mean, even it was a bit before, but that was very clearly established to us during standardization in that group, that we need an independent referenceable document, and the best place for that would be the IETF. And this brought us to this internet draft that we provided here, and what is its current status. So I just noted that this was the reason that we wanted to use root in various STOs, and currently this draft is in its second revision. We are receiving the IETF feedback from the usual review cycle. We are also getting feedback from ATSC currently on the random access signaling aspects of what are documented in this draft. We are also getting some independent feedback from individual contributors who read the draft. They're providing us some feedback. They've come to learn it from ATSC or IETF or different places, and we're getting some feedback. So what is the status of the feedback integration? We received some very nice feedback from different people, also from RFC editor. These were addressed. There was some early review feedback. This was addressed in version 2. We have first external feedback review that's still not completely addressed. We will get second review feedback that needs to be implemented. So these are the feedback that we're seeing very close to the horizon that we expect to receive. There's some ATSC feedback that is still to be implemented. One of the important questions, or I think the main questions that I would like to answer in my slide, is why did we go for the standards track? Why we want to do it as an independent submission? And the main reason for us is that, as it has been commented, that the purpose of this internet draft, the root protocol aspect in a clean, referenceable, or a standalone document, but these aspects have already been specified in ATSC. So we didn't see that we had to do some new standardization. We were just like, okay, take whatever is existing And it's an important aspect that whatever we've standardized in ATSC, it has already been commercially deployed by various TV manufacturers, and we just want to make sure that we don't change anything what is in the route they have used so far. So this is why if we choose, if we change it, then it's going to break compatibility. And from Qualcomm side, we continue to investigate in various STOs that everything is interoperable. And also, a minor aspect is that this is not an independently deployable internet standard. So you need a service layer to make it work. So in that case, it would be an ATSC service layer or DVB service layer or anything later. So I see there is some question from Adrian. And
yeah, hi. So I've got my independent stream editor hat on here, and I just wanted to make clear to this meeting that the point of having Waka present here is that I wanted to make sure that the IETF and in particular the transport area did not want to take this on. This is not sort of asking permission or anything like that to publish in the independent stream. It's rather the other way around. And after useful reviews and comments from Jörg and Gori, who I see is in the queue after me, it seemed like a really good idea to make sure that the transport area was aware of this and give a chance for the area to say, no, look, really, we would like to work on this and we want to push it through, if that's what they want.
thank you. So the next one in queue is Gori.
Yeah, I just wanted to say thank you for bringing your talk here. It's really good to hear people wanting to publish specs for the things that they've made. And I just appreciated you bringing your talk here. I follow the work in DVB, I follow the work here in Flute, and thank you just for bringing this here.
Thank you.
If you need more review from people regarding just the text, I'm sure there's people in TSBWG who would be happy to come in with help in doing your work if that was something that you needed. So I'm just offering that to you.
Yeah, that's obviously something we're looking forward to, more feedback that we can integrate. Yeah, that would be great to have. Thank you.
Lucas.
Hello, can you hear me?
Yes.
Yeah, cool. Yeah, it's kind of echoing what Gori just said. Like, thanks for seeing this, bringing this here and letting us know. About 3 years ago, I was involved in some DVB work where we were weighing up the multicast transport protocol. Flute was an option, route was an option. So some other things were on the table as well. And yeah, like the route stuff was really thorny to like. If we were trying to use this, yes, it's defined in a document, but not very easy. So it's like I left that work, but it's really cool to see how you progressed on. And like I think just making this an informational document would go a long way without lots of changes and all of those things. I do wonder if like in the future, if you were to continue to rev route and like have a route v2, whether that work would be like where that work would be done, given that you have a document here. We see in other places, in things like maybe HLS, for instance, that's predominantly led by Apple, that they continue to work on their specs and then bring a version back to the IETF to be published again. So something like that for root could probably work. I don't know, but yeah, I'm happy to take a look at the document now. I know it exists in the IETF and maybe suggest some editorials or whatever.
Thank you. Yeah, I think this we expect something similar happening. So as I was mentioning, we are getting feedback from ATSC, and the idea would be that these are the guys who've currently most heavily deployed this. that if there is a new need, or for example, this random access aspect that we are looking on into currently, that it's formulated and defined there, and then we bring it back to IETF. Yes. Thank you. There's
Jake.
Yeah, hi. I also wanted to say thank you for bringing this. I think it's really valuable to have it written out here, and it's I think it's pretty good work. One question I think would there be any value in making a sort of standards track service layer that could be done on the internet at large? And is there would that be an appropriate document to set up here, regardless of the you know, I think it makes sense if you're just writing down what's already there. Individual, you know, standards track is, you know, are we prepared to rubber stamp a thing that's already done? I don't know, maybe. But more importantly, would it be possible to make something that is interoperable and generally deployable?
So if I understood correctly, it's the idea that there could be a service layer defined that is an internet standard, and that uses root as the delivery protocol. I mean, yeah, I think it's a great idea. It's just, it needs to be investigated. You know, what are the use cases? What kind of verticals we are focusing on to have this standard? So yeah, I think it's a good idea, but we have to see who are the people who are interested in doing something like that.
All right, yeah, you know, it might be helpful to have a good cross-domain standard for doing this kind of delivery. You know, we were I think some of the Lucas's previous work is something we're considering, but I think that the FEC buy-in, and especially if you get kind of you know, if there's any sort of crossover with other domains, especially, then it might be really valuable to have this kind of thing available on multiple channels. So yeah, I guess I'd encourage following up on that question if that's on the table, and certainly you can contact me to chat about it. I have a few things on my plate, but this might be something that could make the cut for me.
Great, Jake. Thank you very much. I'll for sure. I mean, I think I connected to you briefly on this before, but I'll definitely connect back again.
I sent Adrian a review of this, also a sort of summary review. I'm not sure if I'm one of the ones that you've listed, but yeah, no, I think it's good work, and I think it's valuable to have it documented in the IETF. So thank you for doing that.
Thank you.
All right, thank you, Waqar.
Thank you.
So ahead, did you want to make a closing comment about this, or should we move on?
Yes, so based on, I think, the feedback I've also got, I think the next steps for me are still the same. I didn't notice something different. I get some further very nice inputs that people would like to review this. So my next steps already were integrating reviews, getting more reviews, and then following the publication in IETF as the informational RFC. So I see that this stays the same. And yeah, that's the close of my talk. Thank you very much for listening.
Yes.
Good.
So
David,
yeah, I
David,
think
if
that's
you
a
have
very good
quick
summary.
comment, you can share.
Very quick, was going to very quickly pass along and support Spencer's comment from the chat, which is that because it's really not appropriate to turn change control of this protocol over to the IETF, the track that's being followed here of publishing in the ISE stream is appropriate, and I agree with Spencer on that.
Thank you. Well, thank you, Carr, for your presentation. Zahid, did you have a closing remark here, or?
No, I think, and I mean, we didn't hear anything other than what Walker just said. So I think we're fine here. Andrean, I think you got your question answered, I think, or?
Right. Yes, the last bullet is the correct thing is that it's information RFC in the independent stream rather than the IETF stream. Okay, wonderful. Thank you very much, Carr, for your presentation. And Karsten, you're up.
Okay. So I was asked to say something about how CoAP is taking over the transport area, which is maybe slightly exaggerated. But I thought it might be a good idea to really start a little bit earlier, because the IoT space and the transport area essentially have mostly avoided contact for the last 16 years, and maybe it's time to stop doing that and yeah, work closer together. So I'm going to talk about 16 years of IoT standardization in the IETF on 18 slides. So this will be pretty fast, and I'm not going to go into details, but of course I would love to if people are actually interested. So let's talk about IoT for a second. IoT has been the focus of a dozen or more IETF working groups since 2005. So that really happens in a number of areas: internet, routing, security, applications area, and so on, but just not that much in the transport area. Now, things have always been on the internet, so IoT is maybe not a good description of what we are actually focusing on. The work usually has been focused on constrained node networks. So essentially, we have a situation where our nodes are constrained. The nodes have to live with very little power. They have memory on the order of a couple dozen kilobytes. They have very little space for code complexity, and so on. And it's the constraints on the nodes that in the end influence the constraints on the network. So there are constrained networks. So if you, for instance, have two tanks running through some field and they want to communicate, they may have network constraints, but these are really node constraints, and tanks don't have them as much as say, a light switch. So the important observation here is that not all nodes are constrained. So we don't assume that we have to make every function work on 16 kilobyte RAM node, but IoT networks need to be able to accommodate these constrained nodes. So that's really the interesting part. And what happens is that we just have this immense scaling up in the number of nodes, and that we know how to scale up. That's the easy part. The hard part is scaling down the complexity and the power usage of the nodes, so the whole thing still makes sense. So we are not in the business of taking up the power, same amount of power that the state of Denmark takes, but we want to be reasonable in this area. So what happens is that there are always going to be areas where we simply cannot use internet technologies. So this has the complexity as the x-axis, and there are things on the left side where the acceptable complexity is just very low. The RFID chip you stick to a milk carton, that is not going to be on the internet for a very long time. And on the other hand, you have IoT applications that actually are complicated enough that you would use a general purpose operating system like Linux, and we don't really have to standardize a lot here at least until we come to the security and application area, which have their own challenges. But on the lower layers, that's essentially done. So what we are essentially trying to do is work with the two yellow boundaries to the left. There is a yellow boundary where the internet technologies essentially still can be used unchanged, even if we have constrained implementations of them. And then there is some point where you actually have to change the internet technologies themselves. And by pushing this yellow bar a little bit to the left, we can get a lot of surface under this graph of complexity and count of implementation. So it's really worth doing that. So the first activity that I would explicitly call IoT started in 2005, the 6LoWPAN working group. This essentially was an observation. There is this network called 802.15.4 that can send packets up to 80 bytes. And we really don't want to send a 40-byte IPv6 header over this network. So we need a little bit of more than usual work to actually make this reasonably performant. So an encapsulation was designed. That was easy, 2007. We did two versions of header compression. The first one was discarded. The second one was finished in 2011. And then finally, we actually came up with a different network architecture and a version of neighbor discovery in 2012. So this is all internet level stuff. Well, header compression traditionally has been transport stuff, but the header compression that we are actually doing here is mostly focused on IPv6 and a little bit UDP. So it's really also internet layer stuff. So that's why we never quite talk to the transport area much about the header compression here. So the interesting thing about these 6LoWPANs is they are stub networks. So you're not expected to route general internet traffic over them. They are connected to a border router, by a border router to the general internet, but all 6LoWPAN nodes know that they are in a 6LoWPAN. So all paths through a 6LoWPAN terminate in at least one 6LoWPAN node. So the other side may be a correspondent host somewhere in the general internet, but one end knows it's a 6LoWPAN node. So we can make a lot of simplifying assumptions here. Today, we would call this a limited domain, according to RFC 8799. Because we have this border router that has a very well-defined idea of what is in the 6LoWPAN and what is not. But we didn't have this term at the time, but we felt free to use it, use the idea. And the nice thing of the border router, which is called edge router in this picture here, is that it allows us to have a very different addressing model inside the 6LoWPAN. So we have a single subnet that spans multiple links. The routers route between links that are all in the same subnet. And we can do our own fragmentation, but adaptation layer fragmentation below IP fragmentation. And the routers actually can forward fragments using a trick that was described in the late 2000s. It finally was written up in the 6LoWPAN book in 2009, and 15 years later in an RFC. This means that we really can do strange things in this space because it's a limited domain. And we have been doing stranger things, which are fragment recovery, which is the word that has been used to smuggle a layer 2 wind transmission scheme by the transport area. So there is RFC 8931, which, if you remember my attempts to get local optimizations over path segments thing started, it's essentially loops for 6LoWPAN. So we do retransmission on layer 2.5 for the simple reason that if you have to fragment things and not all of these fragments arrive, then you are really wasting energy. And this fragment recovery draft is really interesting because, of course, it has to have congestion control. And this is essentially the content of the draft in terms of congestion control. So yes, it acknowledges you might need some, but the implementation is free to select the action to be taken, and we expect to build experience that will be written up in future specifications. And there are some drafts out there that might provide wisdom that should help through this process. So I would have loved to get these congestion control appendices in my other documents. But again, this is a limited domain, so maybe we can do that. And the damage that we'll do will probably be limited to exactly that limited domain. Okay, so there have been other activities, or there are other activities also. PWAN is pretty interesting because they are really looking at millibit networks. So we are talking about megabits per second and gigabits per second and terabits per second. But they are talking about networks with 6 millibits per second sustained throughput in at least one direction. And that means your header compression has to be much, much better. And that has been addressed by the LPWAN working group, and it's called static context header compression. So you wouldn't even think about congestion control because you can only send a couple of millibits anyway. So what would that mean? Sending a packet every 3 hours, how do you do congestion control over that? And you probably know about DetNet and the spin-off, the RAW working group, who are doing deterministic networking, which essentially, again, is the limited domain technology. And RAW is essentially doing the same thing over wireless, and is essentially doing all the things that we warned about you shouldn't be doing in RFC 3819. So that's interesting because, yeah, we seem to be able to do a lot of interesting work that wouldn't have gone by the transport area in earlier times. Actually, in the IoT world, we do need transports, of course, but much happens on top of UDP because there are so few opportunities to actually send and so on. UDP is often the appropriate protocol on top of IP. I'm trying not to call it a transport protocol. And so we'll see when I get to CoAP in the next slide how that works. But of course, you can use TCP even in constrained node networks, at least if they are not too constrained. And there is a recent RFC that actually describes how TCP can be used productively in the IoT. And that's used a lot. There is a non-IETF protocol called MQTT that is based on TCP, and that is used in a lot of IoT networks. And it's good that we finally have written up how to use TCP in this space. So that was something where we got a lot of input from the transport area. So that's TCP. TCP and UDP are widely used. There have been talks in the research group about using QUIC in IoT, which is certainly possible. And there also is a reliable multicast protocol called MIPL that has been designed in the ROLL working group, which is part of the routing area. And that is providing something that is almost, but not entirely, unlike IP multicast. So it can be used to make sure that all your lights in the ceiling switch on at the same point in time when you press your light switch. That's the kind of applications. Okay, so let's talk about CoAP. CoAP was initiated pretty much exactly 12 years ago in a Barboff in Stockholm. And we discussed that we would need to cover the full stack to do IoT. And Lars Eggert warned us that a new transport protocol will take 10 years. So we decided, no, we don't want to take 10 years. So we put the transport functions in the application layer protocol. And that is CoAP. constraint application protocol, which was approved 4 years later and published a year later because we didn't think too much about misrefs. We are now much more aware about avoiding misrefs, as you probably are as well. So here the idea was to do this based on UDP, mostly with DTLS as a security protocol. There are other ways to add security, and there are, of course, cases when you don't have security yet for discovery and so on, where you actually go on naked UDP. So our guiding document was RFC 5405, or today it would be 8085, that describes how to properly do a UDP-based protocol. But we definitely didn't want to do anything that would require nodes to keep state about congestion control parameters to their peers. So we designed an extremely simple protocol with lockstep operation. You only ever can start one interaction. You have binary exponential backoff if the first attempt doesn't go through. And if you ever need unacknowledged transfer, that is limited to a parameter. The parameter usually is 1 byte per second. So that's a useful data rate in the IoT. So that's what we thought might be a good basis for unacknowledged transfers, so you don't send megabits per second into thin air. So that's basically the idea, having an application protocol that is lightweight enough on the network that you can run it without actually coming up with a special transport protocol. And I should probably add that CoAP is a REST protocol. So like HTTP, it has a client-server operation with operations like create, read, update, delete. And it uses the REST architectural style, which was described by Roy Fielding. The initiative is on the client and so on. And we try to minimize the state on the server. And well, HTTP cannot do that because there is a TCP connection. So you always have state on the server, even if the HTTP protocol may not be too aware about that. But CoAP really tries to minimize the amount of state that is on the server, because the server is likely to be a very, very constrained sensor that you query using a GET operation. Now, sensors, of course, sometimes have new data, so there is a notification mechanism that is needed. And you know that HTTP has various notification mechanisms that are all hilariously complicated. And we decided we wanted to have those in the protocol and not as backpacks on top of the protocol. So we put in a fifth operation, notification. So you can send a GET together with an observe option, and that means give me the data now, but also give me the data each time it changes. So you get state updates, and that of course requires the server to keep some state. So it's a slight deviation from the basic REST model. So that's the one place where we already got a little bit of state. And yeah, at some point we thought maybe we can actually have some stateful form of or more stateful form of congestion control. And well, CoAP in its base configuration cannot fill a line. You never get more than one packet in a flight. Everything is lockstep, and you cannot even adjust your RTO to a faster network. So binary backoff kind of deals with slower networks almost, but you cannot adapt to a faster network. So if you have a packet loss of 30% because your low power network really has interference problems, you have pretty bad performance. And the idea was to do a congestion control protocol that is essentially based on 6298. So it has a very simple state per peer. And of course, when we designed CoAP, we didn't think about acknowledgement ambiguity. Yeah, that was handled with strong and weak estimators. This protocol was subject to significant analysis. So a number of papers have been published on that. But there was a little bit of an accident because what was analyzed was not the protocol that we were describing, and the difference was actually something where we knew that would be a problem. So we got stuck with that in 2018 and probably have to recover it at some point. There's also an alternative proposal called Phaser, which was unveiled when Coco got kind of stuck, but yeah, that's also currently stuck because the authors are apparently doing something else. Okay, I just wanted to mention it because congestion control is something that transport, of course, is interested in, and that might come back at some point. But the last thing I really wanted to talk about is the blockwise aspect of transport. Of course, the transport protocol must be able to transfer objects that are larger than the MTU. And since CoAP doesn't have a transport protocol, it does the transport of such objects by application layer segmentation. So there's something called blockwise transfer, where in an option you can say, give me the first block, give me the second block, and so on. And at some time you have the whole thing. This is layered on top of CoAP itself, so it's still lockstep. Initiative is on the client side, and it can combine with observe. So if the server tells you there is a new data object, you get the first block with that notification, but you have to get all the other blocks. So this is slow and careful and so on. And well, if you want a better transport protocol, you can of course run CoAP on top of TCP. There is a spec how to do that. And that of course combines well with RFC 9006 constrained TCP. And why would you want to do that and not just do HTTP over TCP? Well, CoAP is orders of magnitude simpler than HTTP, and you get the same simple and short messages. And in particular, you keep the observe model, so you have the state change notifications. Okay, so that's essentially what the CoAP working group thought they were dealing in, and then something happened, which is the distributed denial of service open thread signaling system, or DOTS system. So this is a system that is supposed to work in a situation where you might have DDoS attacks on your system, and you want to talk with some other system to initiate a DDoS mitigation. So you really need to be able to work in a significant distress situation, and that's of course a kind of congestion. So you cannot really use basic the usual congestion control mechanism, because they will just notice, oh, there are way too many packets on this link, so let's send the data very, very slowly. And you know that TCP occasionally gets into these states where it doesn't really make any progress at all anymore. So they noticed that UDP-based communication is harder to slow down, and that CoAP actually provided added value for them. So the under attack channel, the signal channel, can actually run over CoAP. The other channel is your standard REST-conf over HTTP over TCP channel. So they needed something that is a little bit more robust than the basic CoAP protocol. So they designed something called new block, which doesn't mean it's supposed to replace the old block, but it's just new. And this blockwise transfer protocol is much more congestion resilient than 7959, the standard blockwise mechanism. It's no longer strictly lockstep, so you actually can send several packets at once. It can recover blocks that were lost, so we are kind of in the fragment recovery space that we already covered in 6LoWPAN. And the whole set of parameters that govern all this is now actually negotiated between peers. So on the data channel, before the attack starts, one hopes, the peers negotiate what kind of network parameters they're going to assume between them. And then when they actually do their thing, they no longer quite can listen to how well the network works, because the network works really badly when they do this. So this is a very different approach from the normal approaches, and it only works when, again, you are in a kind of limited domain situation. So normally you have a DOTS channel to some upstream provider. So you have a pretty good idea what is between you and your upstream provider. So you may be able to actually negotiate this in a more meaningful way. But it's a rather different beast from CoAP. So it's robust. I would probably call it aggressive. Okay, I have used 25 minutes, and now I'm looking forward to questions.
Thanks, Karsten. So it was the core new block proposal that really kind of caused Ahead and I to say we should really take this to the area, because it's becoming very, very transporty if you take a look at that draft. And that's already through the IESG. But I mean, I would be interested in people's thoughts about the state of this work, and if we need to stage some sort of intervention as an area, I guess is the way to say it. Yeah, right.
Thanks, Carsten, for the presentation. But to me, this presentation made it even more clear that using COPE for a use case like DOTS is just not a good fit. It wasn't designed for this kind of use case. It was designed for small data transmissions in domains where you have like better control than on the internet. And even so, like some of the features might be exactly what the DOTS people want. It doesn't seem to be the perfect fit to me. So I don't know. I wish we would have looked at this earlier.
Yeah, my response to that would be they didn't find what they needed, so they designed the part they did need. And I don't think it would have looked very different if they had done it based on some other protocol.
I mean, based on some other protocol, there's like one option, which is TCP, right? And that would have looked very different.
That would have
looked very different.
Yeah, but would it have worked?
It would have worked because they would probably have needed to design the DOTS protocol differently, right? So that's why I'm saying I would wish we would have detected this much earlier in the process, because that has like a lot of implications. Changing that right now is too late. I understand there are so many dependencies, but maybe the initial choice here was the problem.
So Karsten, is the upcoming work with Core also in this vein of like really starting to push up against the boundaries where more traditional transport constraints like congestion control are relevant, or is this kind of a one-off?
I think this is well, you never know whether it's going to be a one-off, because there may be other people who also have a situation where they need something like this. So it's now an attractive protocol, as we used to say. So other people might find it and say, oh yeah, that solves our problem. Let's use it. But again, we have to be very cognizant that it is meant for limited domains, and it's not something you would run on the general internet. You run it if you know how the network between the two peers actually looks like.
Well, limited domains may be one of the most hated terms in the IETF. But fair enough. Like I I do wonder that if this is, I mean, looking at the TAPS working group and some other things, I've really kind of broadened my definition of what a transport is, and it feels like co-op is becoming a full-fledged transport that needs to be evaluated as such. But I'll let Mira talk now.
I just wanted to comment on the term limited domain because I was having this comment on my heart all the time. I don't think that's the right term here, right? The way limited domain is used is or like in the respective drive that was published on the ISE stream was like something that is connected to the internet, but can be somehow controlled or not, I don't know. But what you're talking about is really a separate network with the gateway. So I would recommend to not use this term in this context.
Yeah, I noticed that despite 8799 being published, we don't quite agree on what a limited domain is, but I'm not so much interested in the term. I'm interested in being able to do things I wouldn't want to do on the general internet, as long as I can make sure they are not done on the general internet.
Yeah, definitely. And as you explained very well, like this was the constraints that CORP was designed with, right? It was like in a domain where you have different or full control. And it was so not the public internet, and it was for like a very specific traffic type. And trying to apply COPE as a general transport to other use case scenarios, I think really needs more work and maybe also more transport eyes. If that's happening, then we should definitely take this on in the transport area. But I'm not sure where this is going. I hope that actually dots was just like one single case, and this is not general pattern that we're seeing. Not because COPE is a bad protocol, but because COPE was designed with so specific constraints in mind.
But COAP does work well on the general internet, so it's not of the same kind that this new block stuff is. So I think you are confusing those two aspects a little bit.
My understanding of dots was there's not necessarily a limited domain, that you have a server somewhere that could be under attack, and then there's an inline, or not an inline, but some sort of like third-party service that you actually topologically quite far from the server. But regardless, I guess the takeaway here, Carsten, is that just as somebody who is involved in this co-op work, if there's additional work that starts to bring up these transport issues, like certainly if it's a rechartering, but even if it's, I mean, Zahid and I will see those, but if it's just like new work that's under the current charter, I think we would appreciate a heads up as an area. You're always welcome to come back and let us know what's going on, and that we can bring it to here, to TSVWG, and hopefully that will avoid some of the worst outcomes in terms of doing things that the transport area would not recommend. But thank you very much for your presentation. Are there any other comments or questions in the queue about this? I don't see any. So Carsten, I appreciate you putting this together. I learned a lot. I mean, this IoT stuff is really sprawling, and it was great to see the high level thing to orient people to this space, because I think it may be coming back to us to hear more about later. So this orientation will be a wonderful thing to point to. And this also gave us a ton of, for those of you in the Jabber, a ton of interesting cheese and toaster puns. So there's that too. So thanks for that, everybody. So now is the time of the meeting. We're about an hour in, but now is the time of the meeting for open mic. So if anyone has anything they would like to discuss about the area with us or with the group in general, now would be a great time to approach the mic. Spencer.
I wanted to thank you guys for continuing the tradition of having transport area director office hours. And I think that it's kind of brilliant that you all do that not in the middle of IETF week, just because it's easier for everybody to talk to you and things like that. I have the last two IETF meetings. I usually wait till the agenda settles down before I upload stuff into my calendar. and that means that I usually miss the AD office hours for TSV because they're the week before. I wonder if you guys have thought about also offering something the week after, just because it's a long time from now until the week before IETF 112. But I know you will do the right thing, and I think that what you're doing is perfect, and I'm sure you'll make the area even more perfect. Thank you.
Well, thank you, Spencer. Zahid and I are both going to be on a vacation next week, so we will not be holding office hours. That said, like if you have something that can't wait, by all means email us and we can arrange an appointment well before 112. I will also actually use this occasion to pitch. There's a TSV area mailing list, tsv-area@ietf.org. And if you're not on it, you're not getting direct email from your ADs very often. It is not a busy list at all, but we do send a couple things like calls for new AD candidates and invitations to office hours. So if you're not subscribed to that and are interested in things like office hours, please do subscribe.
Yeah, and please consider that to be a 112 suggestion.
Sure.
But I mean, like I can find you guys with no problem in my sleep, but not everybody at the IETF can, right?
No, not at all. Beyond Spencer, I mean, I was not just talking to Spencer, of course. If anyone has an issue they'd like to bring up with us, we have a regular weekly morning meeting slot, and we could totally devote that to anyone that would like to discuss something with us if need be.
Right, but that's a good suggestion, Spencer. I mean,
yes,
we can definitely think about that.
Yeah, so we could also look at that option for 112 as well. So thank you. Other Gory.
Yeah, I was just going to ask, how do we see interims going in the next period? We're probably going to need a few in TSVWG. Do the ADs have thoughts about how to do this better? Or are we going to kind of coordinate and spread them out across the meeting interval? What are your thoughts about interims?
First of all, I will say that the IESG is encouraging interim use over this pandemic thing as long as it lasts. Because of the limited number of meeting slots, we've limited groups to 2 hours, and our thought was that as chairs and I think I sent an email to this effect, but for the interest of anyone who doesn't remember that or didn't see it. The intent is that really, even if a working group is like 4 hours of material, there's a certain number of hours that are really kind of the GitHub issues that are kind of for the hardcore, and those do very well in an interim. And there's a certain number of hours that really are good for the greater community. And we asked our chairs to kind of filter that stuff. And if you had more than 2 hours of material, to put the stuff of interest to the community into the main meeting and the rest in an interim. So yes, please do interims. I don't think the volume is so large that we need to deconflict things at this point. I mean, TAPS does interims as a matter of course, and TSVWG is planning at least one, as I understand it, but that may be it. Like there's always a threat of a quick one or a mask one, but I think we're far from having to deconflict that at this point. So please just request the slot that makes sense for you, and we're likely to approve it.
Excellent. Thank you.
Thank you, Gory. Looks like NFS V4 will have an interim too, as what I'm seeing in the Jabber. I think the overlap between that and the other groups is small.
Yeah, I mean they're thinking about it, right? Likely they'll do it. We'll hear from chairs.
All right. Are there any other? Al?
Can I grab you for a quick sidebar and gather after this is over? I don't want to trouble the whole transport area with what I want to talk about. But
absolutely.
Yeah,
we'll see you there. Is it just me or both of us?
It really, both of you could join, and anybody who wants to join can join, in fact, but I just don't want to drag the whole area through it. And I'll buy you a virtual beer.
Thank you for your consideration. It's like
we'll be there.
late in Europe. Anyone else? All right. Well, hopefully, if there are no other comments, I hope you've had a entertaining and informative and interesting IETF 111. We will see you at IETF 112. If things go incredibly well, we will see you in person in Madrid, but it's maybe not. We'll see. And thank you for all of you for what you do for the area and for the IETF, and we will see you later.
Thank you.
Make good choices.
With your help, of course. We'll do that.